Great. Good morning and good afternoon, everyone. Thank you so much for coming today. I'm Megan McClelland. I'm the VP of Product here at Versity. Also joining me today, we've got Nate Schumann, our VP of Operations. We're really excited to be talking to you about ScoutAM today. We have a pretty full agenda. We wanted to go over ScoutAM at a high level, what it's used for, what it is. We're going to talk some about the scalability and performance capabilities. And then we've got a fair amount of time dedicated to a demo for you where Nate will show off some of the latest and greatest features and an archiving workflow and show you reading and writing to that mass storage. And then we've saved a little bit of time for Q&A at the end, although I encourage you, if you have a question, just type it in the Q&A and we'll answer it as we go, or raise your hand and we'll unmute you to ask a question. This is your meeting and we're happy to stop and answer any questions you might have. If I had 10 seconds in an elevator, I would tell you that we manage large unstructured data collections at low cost. Versity ScoutAM is a software-defined storage platform for mass storage and large archive. I think that there are many different use cases with ScoutAM, but the main three that I would really highlight for this is, number one, it's used as an on-premises glacier, and that's for ultra cost-efficient, high-performance, unstructured data preservation. We have a lot of customers who have to keep data for the long term for a variety of reasons. I think a lot of times it depends on the organization's mission and the sector, but the requirement is usually the same. That data has to be preserved. It has to be exactly what was stored, but it has to be available and ready at their fingertips when they need it. For organizations that already have a large archive, it's definitely a differentiated replacement for legacy systems. And those systems that have been running with competitive technology oftentimes are aging out. There's infrastructure that needs to be replaced. It's a great time to look at a different kind of system. And there are several things that really set Versity apart, which we'll go over later in the presentation today. And then the third use case that I would highlight, it's a secondary storage for data lake platforms. And what that really means to me is that it's a much more active use case, whereas you might think of a glacier as something that's cold or something that's sort of on the shelf and air-gapped and far away. We have customers who have a much more active check-in, check-out, use on a daily basis workflow, and that may or may not involve tape, but I think the point is that it's very big and it's very it's a data lake. And it may still be cold, but it's definitely not the coldest deep glacier kind of use case. So I think those are the three main use cases for ScoutAM. ScoutAM is definitely really ubiquitous. It's used all over the world in different verticals. I think that one thing we see in common with all of our customers is that they may have different missions, but there are a lot of things that we see in common where they have really large data collections. They're too big for backups. The backup software can't handle the volume and the namespaces of the data. There are throughput requirements that are fast for both for ingest and for archive and reading of the data. There's almost always a long-term preservation requirement. I have to keep this data for X amount of time. I need to have it. It needs to be available, and definitely cost efficiency and control. ScoutAM is installed all over the world. It has a global install base. We're managing over 2 exabytes of data at 85 sites around the world. It's definitely managing a lot of data, and we're excited to tell you more about it. What's unique about Versity It's an open source file system and file format. You can read the data in your mass storage system with the tar tool that comes on your desktop. It's an open source common tool that you can use to read that data, which I think is really important for users. You own your data and you can always read it. It's a free and perpetual read back. When you're a Versity customer, you can always use Versity software to read your data back. And we have the ultimate disaster recovery guarantee, which means that even without Versity, you could read your data. All of the metadata is stored with the data in the archive, and you could, if you wanted to, if you had to, rebuild that namespace and access all that data with the tar tool without Versity. Not that we ever think you would need to, but you could. And then the one really big differentiator, if you're running a competitive platform with different data formats, we can convert over that archive without migrating that data. So if you're running HPSS, DMF, OHSM, we can convert that archive over to ScoutAM without migrating all the data, which is huge. It avoids a ton of headaches, a ton of time, a ton of babysitting. Anyone that you've talked to that's done a really large data migration never wants to do it again. They take forever, and there are always a lot of complications. So being able to read that data in place is a really big deal. It saves a lot of time. So the different pieces of the ecosystem, and I wanted to cover this early just because we tend to talk about the different pieces and reference them, and I wanted to make sure and talk about what they are at the beginning. ScoutAM is our data management platform. It's the piece that does the efficient management and preservation of the data. It does the data orchestration. It's the piece that systems administrators interact with every day when they're managing the system. ScoutFS is the underlying file system of the data management platform. It's a special purpose created file system specifically for this workload. It's open source. You could use it without ScoutAM if you wanted to, but our main purpose is using it with ScoutAM. And it's very good at search queries regardless of the size of the namespace. And it enables really fast search results and supports mass storage and archiving applications. And then the other piece of the ecosystem is the Versity Gateway. And this is the piece that you can use to ingest object data. And that object data is translated to, in our case, files. The tool, again, it's a tool, it's an open source tool that can be used to translate object data into anything. But in our case, it converts to file. And we use that so that you can see both object and file data in the same namespace. And we use its capabilities to ingest object and be able to archive to tape very, very quickly, very high performance with very low overhead. So those are the main pieces of the system. Some of the main features, the automated orchestration, being able to send data to mass storage automatically and be able to treat different data differently. Not all data has to have the same thing happen. And that's really powerful to automate away some of those headaches of what used to be done manually. Object to tape, I just talked about, very high performance using the gateway and being able to do that. I think a lot of products that I look at in the marketplace are taking one object at a time and sending it to tape. And that's fine for small, low volume workloads. But when you start talking about tons of different users from tons of different places or really big data sets, you really need the Versity capabilities of grouping and optimizing that data and really sending a lot of it to tape very quickly. So that's definitely a standout feature of the platform. The API coverage, there's an extensive API. You can do a lot with the API. In fact, everything that we do in the user interface, which Nate is going to show us a great demo later in the meeting, anything that we do in the UI, you can do with the API. In fact, the UI is API driven. So it's really powerful. You can code within your site to really customize and support workflows. and use those APIs to your advantage. And then the other thing, the system is modular. It grows. When Nate talks about the hardware later in the meeting, the system can really grow with you. When you need your archive to grow and go faster and have higher performance, you can add more and more pieces to where it can grow with you. This is a picture of the GUI on the right. I just wanted to highlight that users don't need to do anything special to use the system. There on the left, it's exactly what I'm used to. I drag and drop files, I rsync them, I secure copy them, I put, I get. It's exactly the same as any other file system that I use. There's nothing special required from me to use tape, to use cloud, to use any of the mass storage options for the ScoutAM system. And for the administrator, there's a great point and click interface. It's really great to be able to look at the information about the tapes and about the system in a GUI, a nice GUI presentation. There is a really powerful CLI if you need to go into expert mode and use the CLI, which also Nate will show later in the meeting. The orchestration engine, really powerful feature that I wanted to highlight a little bit more. I think that a lot of universities tend to have the most complicated policies, and I think they're a great example of an organization having many different stakeholders. Um, there are projects, professors have special projects, there are different colleges, there are different groups, different research groups, and they all have a requirement to retain data for some amount of time. But different projects come with different requirements, and maybe they've purchased things. Some professor purchased tape that they don't want to share with the rest of the organization, or a professor's bought an appliance and, oh, I guess I need that backed up now. Um, uh, some requirements I've seen have a public sharing for a subset of the data. They have to publicly share some of the data for the next X number of years. All of that can be automated away with the Versity orchestration engine. There's a set of policies that you set up for what happens to the data. It can be based on a variety of things. How big is the data? Where did it come from? Who owns it? Those kind of things. And you can automate all of that, which is really nice to have that all automatically taken care of. With that, I will hand it over to Nate to go over some of the details for ScoutAM and talk about some more of the technology.
Thanks. So, yeah, what I want to do before I jump into a demo is just go peel the onion layers just a little bit more, so that you can understand how ScoutAM and how ScoutAM, ScoutFS, and the gateway components work together, how we scale those out, and then ultimately how we bring everything together to create an operational system. So, lots of our customers, we do go after lots of different market segments, as Megan mentioned. So there's lots of different data sources that are coming into ScoutAM. I tend to think of these as really file and object. So file being NFS, Samba or CIFS, FTP, things like grid FTP. And then object, which would be part of the Versity S3 gateway. All of these interfaces are used, can be used individually or all at the same time with ScoutAM. That's really important because I think that gives our customers a lot of flexibility to be able to provide an archiving data management platform for a variety of their users. The core of ScoutAM and really part of the underlying technology that enables us to scale out the platform is ScoutFS. And so when we look inside ScoutFS and kind of the two major components that make up that piece of the infrastructure, we separate metadata and data. The reason why we do that is pretty simple, actually. Metadata is something that describes the archive. It is the namespace. It's what users interact with on a daily basis and how they do things like an LS or a find, within the archive so that they know what's stored, what to go get. And so metadata is always persistently available. It's always online and searchable. Whereas the data piece in ScoutFS is really the landing zone for data coming into and out of the system. And that piece is where ScoutAM, the application, the data management side, is constantly monitoring changes of the data, reading that data, creating one or more copies out on mass storage, which is represented on the far right of this diagram, whether it be object storage that's on-premise or off-premise in the cloud, whether that be tape, or any mixture thereof. ScoutAM is creating copies of data for data protection, and then is also able to separate data out onto different media pools. So as Megan mentioned, in a university setting or in a setting just where there are numerous groups that are using the system, not all users need to, have the fastest access to their storage. Not all users may need, copies on, multiple copies on tape. And so we provide the capability through our orchestration engine or policy engine to be able to decide what to do with the data. The other piece here that I just want to point out, and this really speaks to the way that we scale out ScoutAM. When we're talking about the namespaces, typically we're talking about hundreds of millions and growing into the billions of files within the namespace. And it's really important that we're able to do things like ask the file system questions about, what do I need to do in terms of data? How do I know what data is sitting on a tape? How do I know what data is releasable? And so ScoutAM basically asks the file system questions so that it can carry out its data management tasks without scanning the file system. The other piece here is that, we never actually have to scan the file system. We're basically operating continuously on changes. So ScoutFS gives that capability to us so that we can detect metadata and data changes. So as users are churning through the file system, we're able to easily keep up with that change rate and then apply those policies. And lastly, ScoutAM provides us the capability to do data parallelism. And this is really important when we want to talk about, how we are able to handle, very large files versus lots of small files. And I think most customers have a population of both. It's almost never the case that there is uniformity in, the file size population for an archive. And so lots of customers have to deal with, small files and large files. With ScoutAM, we have the capability through our policy engine, our orchestration engine, to be able to do things like take small files. Maybe I want to create, a disk copy of them. Maybe I want to create them on tape, create another copy on tape so that I can, quickly get a copy from disk. And then if I have to, go back to tape. That's all automated within the policy engine. And what we do with these small files is we actually will automatically read them, package them up in tar files, and then stream those out to tapes. When we're talking about large files, we also have the capability to take a single large file and essentially stripe it across multiple tape drives. ScoutAM will do this automatically. There's really nothing that you as a system administrator would have to do. You just provide the resources to ScoutAM and give it, a couple of different parameters when we're setting up policies, which we'll talk about, and ScoutAM will just do the rest. So we really tried to, gear ScoutAM and how it works to make it easy to, make these data decisions for what do I do with small files versus large files. In terms of how we actually scale out ScoutAM, so we are a multi-node architecture, so you can have, typically 2 or more nodes. All of these nodes are actually mounting the ScoutFS file system. They're all reading and writing both metadata and data. and they're all running the ScoutAM application. And so what that enables us to do is spread the workload of the data management tasks across multiple servers. All of those servers typically have access to the mass storage media connected typically via a SAN. And so that's how we start to scale out both our ScoutAM application as well as our data management activities. A couple other features that I think are really important is that number one, HA for ScoutAM and the file system is built into ScoutAM. So you don't have to leverage something like CoroSync and Pacemaker to make the ScoutAM application and the file system HA. It's already built into the software. So that's just, a couple less things that you have to worry about when deploying and thinking about, setting up ScoutAM. We also support dual site or multi-site replication. That's done typically for disaster recovery purposes. So we've got the flexibility to be able to replicate both data and metadata across a remote site, and then have that data be locally archived there. We also have flexibility to only replicate metadata. So some customers do have the ability to have shared, at least one shared copy of data, and they just want to have a live copy of the metadata in a different location. And so we can do a super lightweight replication just by pushing metadata changes over to the remote site. If we're not doing disaster recovery, and even if we are doing disaster recovery, we still like to have a backup of the metadata for ScoutAM, because remember, the metadata is the thing that holds the namespace, so directories, files, paths to objects, POSIX metadata, but it also has all of the information about the copies that we store. So when we create a copy on one or more pieces of mass storage, we actually attach that information to the file itself. So no matter where you move the file in the namespace, that copy information goes with that file, and we want to back that up. But doing a backup of, several billion files, trying to do that multiple times a day can be a daunting task. And so we've moved over to just doing what we call incremental dumps. So we basically just back up the changes of the file system. We can ship that structure off to a remote system so that in case something happens to our production ScoutAM file system or ScoutAM system, we need to rebuild it. We have the ability to just bring that metadata back, populate the namespace, which also includes the ScoutAM configuration, and get back into production, both for ingest and getting users access to their data. In terms of the hardware components that make up a typical ScoutAM system, so we've got, our ScoutAM nodes that we've already talked about. Our deployment model is a bare metal deployment. So while we talk about Glacier and having an on-premise Glacier, I just want to make sure that folks understand that we're not the product is not a cloud product. It is designed to be an on-premise bare metal deployment. And that's really because we have such a variety of customers that want to secure and patch and manage the servers themselves. Some customers like to have, here in the US, maybe a DISA STIG. Some customers want to have HIPAA certifications that require different configurations of the operating system. And so we're a bare metal deployment to enable that capability. So to have HA, you need to have at least 2 servers. The more servers you add, the more resiliency you have within the ScoutAM system. Additionally, you have more potential front-end bandwidth, so you're adding more front-end network connections to the users and applications, and then you're also adding more potential back-end bandwidth. All of the ScoutAM nodes are going to mount the ScoutFS file system represented with the primary cache here. And again, we have metadata and data separation. And then we have our mass storage target. So I talk about mass storage because almost all customers are going to have at least one mass storage target, and this is where we're making persistent copies of data. And again, we can support all manner of different media as part of mass storage, whether that be on-premise tape, multiple tape libraries, multiple different tape generations within the same library can all be handled by ScoutAM. We can have, NFS filers, and other disk attributes as part of our configuration for mass storage. And then we can do public cloud and private cloud, which you can think of as really on-premise object storage. The box here at the top, which is called extended cache, this is something that is unique to ScoutAM. You could effectively think about it as a warm tier between what's typically all flash in the primary cache and the mass storage, which can be tape or cloud. We'd like to have an actively managed tier to be able to do read optimization for recently stored data. And that's what the extended cache provides. So it's another caching tier within ScoutAM that is actively managed. In terms of, when I think about capacities, because oftentimes customers want to know, well, what's kind of the general rule of thumb for the capacities of these tiers? The metadata storage is really sized by the size of the namespace. So the number of files that you expect will drive the capacity of metadata. The capacity for the data piece is, I think, twofold. Really, it's what's the performance of the overall solution that we need, and then how much data do we intend on ingesting on a daily basis. That will help us to size that cache. So typically that's going to be, say, between 50 and maybe 200 terabytes. Certainly that tier can be much, much larger. We have customers that have multiple petabytes of cache at this tier. And then on the mass storage side, this can be tens to hundreds of petabytes. So again, we've got customers that might have 50 terabytes in their cache, but have 150 petabytes of data being managed under their mass storage. So that really varies depending upon use case and what how much data you intend on managing. And then the extended cache is typically somewhere maybe several hundred terabytes to single digit petabytes. The way that I typically think about sizing this piece is really how much data do I want to hold online, like how many days worth of data do I want to hold in a fast access tier, rather than going to, say, tape, or even if I was doing something like only archiving to public cloud, I might want to have an extended cache so that I can store recently stored data in the archive without having to reach back into that cloud storage provider and potentially get egress fees if I want to pull that data back. So these are the hardware components. Again, we're most often our customers will come to us, or we'll ask a few key questions to help to understand what this hardware footprint really should look like. There's a question about ECS. So ECS actually can play in both. ECS is Dell's object storage. So that can be both what we label here as private cloud. So a mass storage copy can certainly be on ECS. And then, obviously it can be part of the extended cache piece here too. Lots of customers, as I mentioned in this diagram, where I have to have small files, deal with small files, and I want to, and I also have to deal with large files. A very popular way to help optimize dealing with small files is also to leverage something like ECS in order to have one copy of those small files on disk, maybe another copy on tape. So I will almost always go to the disk copy first because that's super fast. And then if I need to, I can go back to the tape. So that's where, ECS and other object storage can really come to play in a ScoutAM system.
And just to add, we have an OEM relationship with Dell Technologies. We have a turnkey solution that you can buy through Dell Technologies, and it's Dell servers and SAN storage and object storage, and it's a turnkey one-stop shop that you can do through Dell with Versity.
That's right. There is a question here asking about tooling to move from older types of technology to new types of technology. And the answer is yes. That's an operation that we call recycling, which is basically reading any valid data off of, say, an old piece of media. Let's say LTO7, and you were doing an LTO7 to LTO10 upgrade. We would do a recycle of that media, archive that, the valid data to LTO10, and then we can get that LTO7, those LTO7 tapes off the system. I think it's also important to note that all of the components here, whether it's the servers, the SAN storage, the mass storage, the extended cache, and thank you for that question, by the way. This is really designed to grow with you and change over time. So we all know that tape, that technology changes, server technology changes, disk technology changes, mass storage technology changes. And ScoutAM has the capability to grow and change with those technology changes. Some of the customers that we have, in particular, say national libraries, have missions to store data for extended periods of time, multiple decades. And so they need to have the capability to be able to do that migration from technology to technology, and ScoutAM enables that capability. Okay, so we talked about the features and how ScoutAM works at a high level. And for folks that are thinking about a greenfield archive where, hey, I don't have an archive, I want to put an archive in, I want to do something with ScoutAM. That's really great and easy because there's no legacy data that we need to handle. But as Megan mentioned earlier, we do have the capability to bring on existing archives, whether they be, HPSS, DMF, Oracle HSM, and we're constantly adding others to the system. We basically can pick up the metadata from those products, bring them over to ScoutAM, basically put the namespace back into the ScoutAM system, and then natively read the archive storage. So this gives you the capability to do what we call an in-place conversion. There's no data migration. There's no need to take time to read every single tape and then rewrite it out to new tape. We can onboard you with one of the supported platforms in a very short period of time. So if you're thinking, I've got several hundred million files, I've got 50,000 tapes, I've got 100 petabytes of data, how the heck do I get to ScoutAM? Well, the answer is the in-place conversion, again, bringing that namespace over to ScoutAM and then have ScoutAM just deal with it. So I think this is a really important thing just to think about when thinking about a new archiving platform that you want to bring in. Okay, so enough with the slides. We'll switch over to a live demo of the system so that you can see how everything works. So I'll stop sharing slides and I'm going to switch over, if I can. Just bear with me for 1 second. I'm going to share my entire desktop. And just want to make sure that you can see this. Megan, look good?
It looks great.
Okay, great. So, I want to show both the CLI on the right as well as the GUI. Just because I know that there are lots of customers that, have various preferences. So the CLI on the right-hand side is called SAM CLI. And this is, a centralized location for commands for doing everything that you want to do with ScoutAM. For example, if I want to look at, SAM CLI Arch set, if I want to look at my archive policies, I can do that and look at it in a text format. If I want to look at, the archive policies in the GUI, I can go and look at, these policies.
Nate,
Personally, yeah.
we have a question. Could you back up a second and just describe the demo environment? Like what's our hardware setup here? What
Oh
kind
yeah, I'm
of are we
sorry.
running
Yeah.
on?
Thank you. Yeah. So this is all in VM. So essentially what I've got are 3 ScoutAM nodes. So because I don't like to type, I call them S1, S2, and S3 for short. These are all mounting the ScoutFS file system, which on the right-hand side is just mounted at MNT ScoutFS. And in the background, I actually have a constantly running process that is writing data into ScoutAM, releasing the data, and then staging it back, and then just doing that over and over again so that you can kind of see, what the different displays look like as data is moving through the system.
I'll also, I'll also point out, because it's Joe who's asking, we're running in our Versity test lab. This is on a Dell PowerVault. It's an ME5 and R750s, I think.
Yeah. So on the right-hand side, the namespace for the file system looks like, any other file system that you're probably already used to, whether that be ext4 or XFS. So what that means is basically, you can use things like NFS or CIFS to export the namespace to get access, for access to users. As well as you use our S3 gateway in order to have an S3 view of the same data. So here I'm showing on the right-hand side, a file POSIX view, and on the left-hand side I'm showing an object view. So I'm just using CyberDuck as my platform here. And so, I can use S3, I can look at, the info for these. And, when we do when files are actually in the offline state, users can see the storage class change from standard to Glacier. And they can also see if there's an ongoing request. And so this gives users a lot more detail as to what's going on in the system. So here I was in a bucket called users, a folder called Versity, and then I can see the into CD into ScoutFS users Versity. Yeah, if I could type, and I can see the same files. The difference here between the S3 view on the left-hand side and the file view on the right-hand side is that I can get quite a bit more detail on what's happening with these files via the native ScoutFS interface, and then I can also get that information through the REST API. So if you've got users or service accounts that want to be able to get this information, but you don't want to have them have direct access to ScoutAM, they can have access to the API and they can get this level of detail if they want. So to see again, what what the POSIX information is for a particular file, what the state of a file is here. So here we have offline, which means that the file exists in the namespace, obviously, because I can do a search and I can look at it through the object interface. But the data portion is actually not online. The data portion is sitting out on, in this example, LTO5 tapes. So you get quite a bit of information about the state of a file and whether there's an ongoing staging request. And then we have all of the copy information for these files. And so this copy information is all of the information that we need in order to go back into the mass storage and retrieve that data. If you're moving files around in the namespace, I think I mentioned this earlier, this copy information goes with it. So you can do a move from one directory to another and nothing really changes. So that copy information goes with it. So we've seen the interface for users via a file interface. We see it via a gateway interface, and then now let's look at the policy engine for a second. So what I've done for my system is I wanted to create 2 copies of data, and I wanted to actually create those copies onto 2 different physical tapes. So what I've done is I've created very simply 2 different media pools. I called them copy 1 and I called them copy 2, and then I've assigned them resources. If you have a much more complicated user, or I'll say maybe not complicated, but a much more diverse user base, and you really want to be able to separate data for those different projects, for those different users, whether that be by path or by UID, GID, or size, you can create additional media pools and then point the policies at them. So that's what you would generally do, is create your media pools, assign resources, and then go and configure policies. So policy is very simply the what and the where. What, where, and when of how to do data management. So here I've got a policy just called all data, and the matching criteria that I've selected is path, and path is a regular expression. So if you've got a certain file naming scheme where there's files kind of peppered all over the namespace and not really in a very predictable location, you can use regular expressions to be able to pick up those files. I can then add in additional criteria. So let's say I want to, do something for a particular user ID, and I want to point, user ID, say 5,000, and I want that user to have just 1 copy on a very specific set of media. I can do that by adding in additional matching criteria, or just having 1 matching criteria for that particular UID. So the more matching criteria you add, the more specific you can get. So the other ones are GID, and then some size information. Again, if we want to do something different for large files versus small files, we want to do something different for a particular group. And then we will be adding in project IDs so that you can do archiving via projects. So these are logical ands. So everything needs to be true in order for the data to match this particular policy. And then we add in our copies. And again, our copies are basically definitions of where we want to send the data. Again, I just have a very simple policy here where I've got 2 copies going to a copy 1 pool and a copy 2 pool. And then I have start parameters, which basically dictate how long do I wait, how much data do I wait in order to send that to that particular media pool. So for tape, what we typically do is we'll make a start size of, say, 100 gigabytes. something in that range so that we've collected enough data to efficiently stream data out to tape. For disk, we can be much more aggressive, so we can make that start size smaller. We can make the start age smaller. But essentially what you do is you set, the parameters based on the media and your business requirements for that data protection when that needs to happen. And then this is a logical OR. So any one of these parameters that matches first will start scheduling the archive job. So there's quite a bit of flexibility in terms of when this data needs to go out to tape, or excuse me, tape or object or cloud or any of the other technologies that we support. And lastly, I just want to point out that ScoutAM, we are a data protection mechanism, data management mechanism, and so we want to make sure that we are always have data correctness and validity in mind. And so we always are generating a hash. So in this case, I've chosen SHA-1, but we can do MD5, SHA-256, all the way up to SHA-512. So when we're archiving that data, we're generating a checksum. And every time we're reading that data before we hand it back to the user, we're validating that checksum to make sure that we are providing valid data back to the user and the application. And this just happens all transparently. There's nothing that anybody has to do. ScoutAM will just, once you set the policy, ScoutAM will take care of it. A couple other things I want to point out here, because I know there's going to be customers that have lots of admins, lots of users, lots of different people that might be accessing the management tools here. We do have different roles. So you can have, a role from, by default, we have super admin, which can do everything, admin, which can do everything but change account information, operator, and everyone. So basically, least permissions going to the left. And then you can create your own roles. So if you have different workflows and different needs for different individuals or different groups of individuals, you can really customize what they can do in the GUI, as well as what they can do in the API. So I think, as Megan mentioned, everything that you can do in the GUI, you can do via the API. And so if you want to do some more automation, you can add in new roles. And then, of course, you can add in different accounts and different users. I glanced over the dashboard, but I want to make sure I want to touch on monitoring of the solution. So we have the dashboard here, which gives us a quick view of the servers that I have. So again, I've got 3 servers. They're all configured as quorum, which means that they're all in an HA configuration. So in this case, if I lost one server, I could, the whole solution will keep going. If I added, say, 2 more servers, so I have 5 quorum nodes, then I can lose 2 nodes and so on. So the more quorum nodes I have, the more resiliency I have in the solution, as well as, more potential bandwidth. But I also have numerous resources here. So I've got, a few different tape libraries. I've got, my cache, which I want to make sure is healthy. And then, of course, I can look at, how things are being used, right? So how much media I've got, what the state of the media is. And this is all, really important information for at a glance, like, is my system healthy? How are things running? I want to be able to just quickly look at the dashboard and understand that. We also do have notifications. So here you can see I've restarted ScoutAM a few times. And so you can see executor 1 disconnected. I've had some resources go offline. We have this notification mechanism, which by default goes to the GUI, but you can also send these notifications to Slack, email, PagerDuty, and numerous other backends for different notifications. And then, of course, if you're looking at the API, you can also get these all via the API. So you can create your own dashboards from the information that we have in the GUI. It's quite a bit of flexibility when it comes to actually monitoring the ScoutAM system. We do have reports as well, and this is one cool thing I like to see. So the cache usage is very interesting, but what I really want to see is who's using my resources. So one of the things that we've done with ScoutAM is to enable essentially always on accounting. So whether I'm looking at this via the GUI or if I'm looking at this via the command line, I can actually see, all the users that have data resident in the cache. In this case, I'm looking at online statistics. So I can see, the user, I'm just using, users in Etsy password. So the user root here has 15 files that are online and it looks like about 154 megabytes of data resident in the disk cache. But that user could also have a lot more data out in the archive. So here I've got, a user 6355, which has, 20,000 files and a ton of data in the archive, but really nothing in the disk cache. And so actually nothing in the disk cache. So this is really important information for you to be able to actually see what users are using the resources. The same will be true of group IDs and then project IDs as well. So you really start to get some important insight into who's doing what. And then lastly, before I leave a few minutes to make sure that we've got some Q&A time, is the dashboard is really geared towards what's happening now in the system, but we also have extensive stats D metrics to be able to export that information for your own consumption and your own visualization in, say, things like Grafana, etc. Most of our customers have their own monitoring infrastructure. And so they'll want to be able to look at this data to see, okay, well, how is the system performing, right? So here I can see archiving and staging performance as a whole. I can see, how my work is actually distributed across different nodes, different tape drives, how much work is actually sitting in my scheduler in different states. And then, how much capacity have I actually used out of my tapes? And I can do this, with a tool like Grafana. I can, start to zoom out and really look at, how this system is being used. And especially if you want to look at much longer term, metrics for capacity planning, then this type of information starts to become really invaluable to help you make some really key decisions on, my data volume is growing, I need to, number one, probably add more tapes. But I can see that, I'm constantly using a lot of my resources. So maybe I want to add more drives. Maybe I want to add, an ECS to offload some small files, or do some other things to improve the system over time and just add more capability to it. So I think that's a really important thing to also see and understand our capabilities. And with that, I'm going to stop here and I'm going to switch back over to the slides. And we can open it up for additional questions, but I also want to make sure.
We've
Yeah,
had a lot of really good questions in the Q&A.
good. I've been talking, so I didn't have a chance to see them. Thank you, Megan, for answering those. Before we do go, the answer to the question about quotas is yes. UID, GID, and project ID quotas. but I want to make sure that before we go, we're just about at the end of our time, to make sure that we're here for you. We're here and able to set up a self-guided demo. We can also set up via like an AWS instance of ScoutAM. We're happy to show a demo, a one-on-one demo. We can do proof of concepts. Those POCs can range from just an instance of ScoutAM in the cloud to a VM in your data center to, all the way to, kind of the full blown, I really want to see this thing scale out. So we've got quite a bit of flexibility in POCs. Pricing, quoting, Megan can help with that, sales@versity.com. So really, we're here as a resource for you to be able to ask more questions and then to ultimately, get to that decision-making thing. So with that, Megan, any closing comments?
One more call for questions. Any other questions? Maximum cache size. Ooh, that's a good question. Well, I've seen up to 5 PB in the field, but I don't know if there's a
That
theoretical maximum.
the theoretical it's a 64-bit file system, so the theoretical maximum would be 2 to the power of 63 bytes, which is, large. So there's a practical limit and then there's a theoretical limit.
I'm going to record that one in here so we have it. How many copies of a file can be made? It's unlimited. You can do as many copies as you want to. And can the second copy be made prior to the first copy?
The answer to that is yes. But I will say that, before we release a file from the disk cache, we like to have all of the persistent copies made just so that we don't have to read back from a copy and then create another one. There are some rules of thumb for designing the front end caches and for serving the workloads. And really, that's mostly around the performance requirements. And you can really boil it down to, how much data do I anticipate on ingesting in a given day? That helps us to, take a good a good estimate on what the performance requirements are, which decide how many servers, what that disk cache needs to look like, all the way down to how many HBAs and how many things do I need? And at Versity, we're very happy to help with that. Is there a concept of tenancies in ScoutAM? So in the file system itself, so multiple tenants, I think that's what the question is asking, multiple tenants. Basically, from a file perspective, we adhere to POSIX permissions. So users, groups, projects, those types of things. So from that perspective, ScoutAM is multi-tenant. When you start layering on services, so NFS, CIFS, etc., those also have their own capabilities to authenticate to different ADs, LDAP. And so we do multi-tenancy really through the operating system. So we didn't mention what operating system we run on, but we do run on Red Hat Linux. Today it's 7 and 8. RHEL 9 will be coming as well. And whether you're using RHEL or a free alternative, Rocky Linux, Alma Linux, that's fine with us. But we really leverage those upper level software components to be able to provide the multi-tenancy when we're talking about the file interfaces, so CIFS, NFS, etc. When we're talking about the Versity Gateway itself is multi-tenant. So we do have IAM policies. What's really cool about the gateway, especially when we're thinking about how you do translation between S3 authentication, which is usually an access key and a secret key, which has no direct mapping to a POSIX UID and GID is that if you have the ScoutAM, IAM policies backed by, say, an LDAP server, you can actually put in a UID, an access key and a secret key along with that UID. And then when somebody uploads an object authenticated as that access key and secret key, we can change the ownership of the final file that lands in ScoutFS to that UID and GID. So we really can start to get a much more seamless translation between object and file. So I, as user NDS, can write my object, and then if somebody's in my same group and they have access to my directory, but they want to get something via NFS, they can do that as well, because we do that access key to UID mapping. There are no, so there's a question about can CIF Samba users have access to previous versions for data historics? I'm assuming that's different versions of files. So there's not strict versioning within ScoutAM. One thing that we can do is actually leverage our incremental dumps to be able to go back in time in order to go get a different version of a file. So, for example, if a user wrote a file, it got archived, we did an incremental dump, and then they came in and deleted a file or modified a file accidentally or deleted a whole directory, we can go back to a previous increment and then restore that object or restore that file or restore that directory and get them access to an older version. It doesn't change. So there's a question about code reviews and security. So our code reviews are all internal. We do regular scanning of systems running ScoutAM. So typically using Tenable or different security scanners. I don't know, Megan, I think we're doing, in our CI/CD pipeline, there's other security mechanisms. We don't generally talk about those, but yeah, we are doing scanning of code and things that we use inside the software.
One thing I will say in terms of that, we're happy to talk to you about some of our reference accounts who use Versity's ScoutAM in very highly secure environments that have very strong compliance requirements. We're happy to talk to you more offline about that.
Looks like there's a question about, I guess your FS doesn't change object storage, but rather indexes data that it placed there. Yeah, so when we are, I assume this question is about archiving and like saying pushing data to something like ECS. So when we archive data to any actual mass storage, will the initial archive will be a file or a tar file out to tape or a file out into the object. If that file in ScoutAM gets modified, we'll actually create another copy. So we don't overwrite data, whether it's in being archived to object or to tape. That gives us the ability to go back in time and get different versions. That also does mean that there can be stale data, meaning there's files that maybe don't exist in the file system namespace anymore, but there's still data bits out there. We actually understand, how much stale data is in our solution, and we can do things like recycling, which we talked about a little bit ago. So recycling, again, is the process of, I got to read the good data and then re-archive it to, another tape, or, re-archive that object to mass storage. That's how we start to get rid of older versions and also reclaim stale space. So scale up would require how many helpers to recover old versions? So the number of versions that we would be able to recover are really dependent upon how often we do incremental dumps and how often we recycle. So if you don't recycle very often and you're doing, quite a few incremental dumps, then you're able to go back in time further. This is really an administrative process to decide how often I want to do this and how aggressive I want to be in terms of um, reclaiming stale space. Uh, Quotas apply to both online and offline files. So basically, we prevent in the online quotas, we would prevent net new writes and give you a quota exceeded. And then we also have an enforcing quota for offline data to prevent a user from, or a group or a project from, like, just consuming all of the media in a particular media pool.
Yeah, and it's and the answer to the question, yes, you can do online only if you want to. It's online and or total for each UID GIDR project.
Right.
Both size and count.
Yeah. So I think I answered the previous versions question. There's a question, is Scout SAM QFS grown up? Well, that's a little bit of a loaded question, I'll say. So if you're familiar with Versity and you're familiar with our software lineage, SAM QFS was a product that came out of a company called LSC, went to Sun, ultimately to Oracle. They did an open source spinoff of that in 2011, which is when Versity was founded. We ported the open source version of SAM QFS to Linux, and that's what became Versity Storage Manager. We didn't mention Versity Storage Manager in this talk because really, that's I'll say our legacy software. There's still tons of users that are using it. We're still actively maintaining it, providing fixes, etc. But it has some limitations, right? So one of the limitations is you can only have one node that does all the archiving, one node that does all the metadata updates, etc. And so ScoutAM was actually we started developing it, I think, about 4 years ago, maybe a little bit longer.
Longer.
Longer. Thank you. With the idea that we wanted to have, number one, a scalable solution that can go beyond just a single node, a more modern platform that we can fundamentally add tons of cool new features and really be able to iterate on it much faster. Provide cool things like a GUI, and all these other things that just based on the history of how VSM evolved would be very difficult. And also, again, to make it very easy to use and to manage and to scale up. So whether this is SAM QFS grown up, I don't think I would say that. I would say this is really a modernized data management platform to get us moving to where our customers are going, which is, on the high end, the exascale side. That's on the extreme high end, but we needed, a ScoutAM and its architecture to be able to push in that direction.
I think to summarize, ScoutAM really benefits from the rich legacy of VSM and the products that came before it and the team's knowledge. I think we tried to count one time the years of experience on this team for people who've been involved in archiving products. But we knew with the massive growth of data, and it's not slowing down, that we needed a brand new clean whiteboard design to be able to handle incoming data and deal with today's data sizes and be able to archive at the speeds we need to go. So our vision was really to make the most capable mass storage platform in the world. And we really couldn't start from an existing product for that. So yeah, it's a brand new clean whiteboard design, but definitely lots of experience and rich legacy that came as part of our previous products.
I will say one thing. We talked about the zero data migration conversion from third-party products. You can obviously do that going from VSM to ScoutAM. So it's quite easy to go from, to go from one to the other.
All right. Well, we are over time. I apologize for going over, but we're happy to stay. There's been such good questions. Um, Last call. Any other questions before we go?
There's a question here about media reclaim is an important issue for high churn environments. That is that process of recycling. So recycling, we leverage the recycling workflow to reclaim space from tapes that have lots of stale data. We use the same workflow to migrate data from one version of media to another. So LTO8 to LTO10 and so on. We use that recycling capability to create a copy, recreate a copy of a file or files that might be on a bad tape. So that term recycling or that workflow gets used in multiple different ways within ScoutAM.
All right. Any other questions? We're give it one more. Going once, going twice. All right. Well, thank you so much for attending today, everyone. We will definitely send the slides and the recording of the meeting to the email list. For those of you who registered, you'll get a copy of the slides and the recording. Thank you so much again for your time today. We really appreciate you taking time out of your busy day to join us and learn more about ScoutAM. Have a great day, everyone.
Thank you. Take care.